Howdy, I'm Connor Burke with Excel Tech Solutions, and I get to talk to y'all about some best practices for large public venue. So first off, kind of have to define what is large public venue. There's a bunch of different options for it. Specifically for what we're going to look at today, though, we're going to look at stadiums, both open air and enclosed, as well as more convention center type deployments. One note for both of these, and either way, one of the biggest aspects you can do is get the architects involved early. For any large public venue, you're going to have really public-facing infrastructure, so it's much easier to get them involved up front to be able to say, hey, can I mount this here, or like, where can I not mount? Then you get it out there and design a perfectly good network, and then they'll come back and say, you can't use half these locations. So always get them involved as early as you can. It'll make your life a lot simpler. So looking specifically at stadiums and arenas, so there's obviously the multiple types. There's open air and enclosed. Open air being a standard one for football. I'll kind of leave that vague as to which football I'm talking about in this crowd. But enclosed is typically used for basketball, hockey, or any musical events. So we're going to look at those kind of deployments, and they both have positive and negatives based on whatever design methodology you go with. There is a couple different design methodologies that we actually want to typically use in these environments. They're all great, and you can design for any environment with any of these solutions, but there are benefits and detriments depending on which one you go with. You can choose per section kind of which one of these methodologies you go with, but it is highly not recommended that you use the multiple methodologies into a single area. The biggest example of this is if you were to try to use an underseat and an overhead deployment into a single section. Often what will happen is that you'll have attendees come in, they'll sit down, they'll associate with the underseat, but as you get more attendees coming in and they fill that up, you get the extra body attenuation. Then the client device will roam to the overhead, and even as people leave, it won't roam back to the underseat. So you'll overload the overhead. So it's typically best to keep everything the same within a single section. You can divide the sections differently, but don't mix them in between. For underseat, there is a lot of benefits to it. The biggest benefit is for when you're using open air solutions. That's typically because you're limited on your mounting options if you were to try to do overhead. But it can be difficult at times because every stadium is going to have a different seating, whether that's the height in between them, the space you have reaching out from it. So you have to be very considerate of that, and that's why you need kind of a custom solution every time you do it. We have a couple varieties of that, but there are others on the market that also do a great job. The negatives that you kind of see with underseat is kind of how we were mentioning earlier. The coverage changes depending on what your actual attendance level is. So if you have full attendance, that's easy to plan for, but if you're at 75, 50% attendance, your coverage is going to change pretty significantly. So you just have to be aware of that and be ready to kind of do some mild management to get it to be optimal again. Another benefit for it, though, is that it is very easy maintenance. It's right there on the ground. You don't have to get a scissor lift. You don't have to go up into the rafters. You can just go in there, take off the torque screws, and if you need to do any maintenance on your active equipment, it's really easy to get to. When you're actually going to design, though, obviously it's typically a challenge. You think, okay, well, I have the slope. I'm putting my AP in there. How do I actually design that if I was trying to do a network? Well, our typical best practice is that you want to match the grade or whatever the angle of the stadium seating is if you're using internal AP. So really, if you think about it, if you're matching the grade of the stadium, you're basically designing on a flat plane then if you were just to put the human bodies. So what that allows you to do then is just go into Ekahau as you normally would and plan on a flat surface, no tilt or anything from the ground, put your human crowd attenuation area, and you can go in and still easily design with it. So it makes the design a lot simpler than you imagine it at first. It can be much more convenient. Going to the actual AP that you have in there, the internal down tilt that we were kind of mentioning earlier, all these Omni antennas that are in the APs actually typically have a down tilt. It's around the area of 5 degrees. It's not much, but it assists in just a typical office space or carpeted area to get the signal down a little bit closer to the ground. That actually helps you here a little bit because they're able to push through those bodies a little bit more that are sitting on top of the AP. So it's not only a benefit when you're using it in a standard deployment, it actually helps you here as well. But not every deployment are you going to be able to use the actual internal AP. You may have aesthetic requirements where they say, I don't even want to see an underseat enclosure, or you may have physical limitations. It may be a case of, well, this is really narrow seating, it's just a bleacher, it's only 6 inches deep. What can I really do then if the underseat sticks out a foot? Well, in that case, you can look at using external antennas and using a smaller enclosure. So like in this case, you can achieve the same thing with the same number of APs, but instead of having a full-sized underseat enclosure, which is typically let me do a conversion real quick, half a meter by like a quarter of a meter. You can use a smaller enclosure that just houses the antennas that's only 250 by 150 by 50 millimeters in size. So you can get a lot smaller area while still keeping that performance. And it also keeps their actual active equipment safer because it's typically going to be mounted under the arena then. For overhead designs now, there are different ways. This is typically best for when using an enclosed area, and that's primarily due to that superstructure that you'll have on the right there. It's not working. So you have the superstructure that you can actually easily mount to. That typically doesn't exist in a more open air environment. You can still do it, and we'll actually look at a case later on. But for enclosed arenas, it is the preferred solution because you're able to get very isolated cells of coverage that aren't capacity dependent. You can make these cells without having to worry about if you're going to have 50% capacity or 100% capacity because it's always going to be the same overhead. It's going to be very limited on how much it's affected by your actual capacitance. Another benefit to this is that it is typically a cleaner aesthetic. Most people aren't looking up into the rafters, and even if they are, you can actually get antennas or enclosures to match the ceiling. So if it's a black ceiling, you can match that and just make it completely disappear. So from an aesthetic standpoint, it's much more preferred by architects in that regard. You do see more reflectance when using this design, though, mostly in the enclosed arenas. That's just because it's in a smaller arena typically. A pitch is much larger than an actual court for basketball or hockey. So you're going to have to keep that in mind that you may see a reflectance from across the arena and actually hear those other APs a little bit. And same thing as when we were looking at the underseat enclosures, though. It's still all a matter of perspective. Again, if you're matching the gradient of the stands, you can just tilt your stadium seating, and you can design that way. But another way to look at it is even if you're not doing that, if you do have it at an off angle, if you're using antenna with asymmetrical beam widths, you can still do trigonometry. You can still just say, okay, well, I know I'm 5 meters away from the chair forward, and then the AP is 8.6 meters up. That's going to be 10 meters away in respect to the AP and the antenna if you're going flat. That can also be done using trigonometry. If you do want to do it at an off angle, you can just use a simple trig function. And a laser rangefinder is definitely your best friend there when you're doing these stadium deployments. And I know we're talking about using MOL for the Sidekick 3, so maybe we can add a laser rangefinder to the V3 as well, keep adding those features up. And you can go in and design like normal, though. There's just a couple options of some typical stadium ones from both vendors and us, and you can design a pretty concise network with real high density to keep that client association to the APs lower than you need. And you can also do this outdoor. You're going to be limited on the mounting options, which is why typically underseat is preferred. But if you're going just for coverage, typically to now we've been talking about actual density, the capacity that your network needs. But not every network needs to have amazing capacity. It may just need, hey, I need basic coverage here to provide something to my crowd. Well, in that case, you can use these more just coverage-based solutions that cover a wide area from a central point here, like on the bleacher box. And you can still cover these areas. This is actually a solution we did with Arista and Bullock over in Georgia, to where we did the same thing indoors as well. So not every application is going to be the super high capacity. They're going to have just coverage requirements of, hey, we need to be able to get this. Handrail antennas is the final option that we kind of see as the popular design methodology within stadiums and arenas. It's slowly been phased out more in favor of underseat, but it still does have a place. The reason why it's been phased out as of recently is because it sees a lot of the same issues that the underseat does, to where it is very capacity dependent. As your stadiums change, it can change what your actual coverage is. But the reason I think underseat has become more in favor of it recently is because it doesn't have any of the EDA compliance or ADA compliance, because some arenas require you to have a certain spacing within the handrail and whatever you're mounting to it. And we typically can accommodate that, but it is always a concern. So underseat has become a little bit more popular, but you can still achieve the same result by using handrail. And we did this with another large public venue over in Milwaukee, the Milwaukee Bucks, to where we covered their entire bowl arena with our handrail antennas. And another point that we haven't really talked about yet is how do you actually cover the concourse area, the ring around the actual bowl that has all your food, has your points of sale. You need to cover that as well. Typically that can be done by just using a standard internal AP mounted to the ceiling, but depending on if there's higher aesthetic requirements, you can use an enclosure that looks like a, it's not working, that looks like a section number that you see there in red on the left. or you can use another aesthetic solution like a skin or a vinyl wrap. All these have in common, though, is that they're all going to be slightly different. Every arena is different, and an interesting thing that I learned through going through this and a lot of our partners is the physical materials matter a significant amount. Concrete that was made pre-1980 is significantly more RF absorbent than newer concretes. It doesn't have as much metal into it. So you really need to go out there and physically survey it to determine what your environment needs. Otherwise, you're not going to be able to design it properly. Convention centers are the other aspect of this. Convention centers have a lot of challenges that we don't actually see within a stadium or an arena deployment. They're the same high density that you see, but it's a lot more mobile. Whereas you can kind of accommodate everybody and plan on everybody in a stadium being in a single space. They have their seat number, maybe at halftime or in between quarters, they'll move away and go do something else. But in a convention center, it's constantly moving. Whether they're going to different booths or they're going to different sessions for their teachings, it's always going to be moving. So you kind of have to really think about that and how is the roaming going to affect all this. These environments are typically not your own, so you have to accommodate what the aesthetic requirements of the actual convention center is. They often will fight you on, hey, can I put an extra network in here just for this one event? So you have to really focus on that. And your average user use will typically be a little bit higher. The peak for a stadium is extremely high, especially on the actual user upload. At halftime, people are trying to go in, upload their videos from, hey, I just took this halftime video from the game, and they do that. So you'll actually see the highest peaks there, but the average use will be higher typically on a convention center. And then you also have to consider rogue APs. So in these environments, individual vendors will go in and they may be doing a demo of some kind, and they'll set up their own network, and then you have all these rogue APs in your entire environment that you didn't account for. So it's much more complicated in that respect. But you can kind of account for that by having much more isolated cells of coverage. So like this solution here is actually 4 APs that were able to be mounted to one spot. So they're very directional APs, 30 by 30, and you're able to put 4 of them and a switch, so you could actually run fiber and DC power to it, and then have those have isolated cells so that if anything goes wrong, if there are rogue APs, if you need to have more tight roaming, you can have these really small cells. And you can get really high density with this. So this area that we see here on the right, that's only 60 by 60 meters. So it's a real small area, and there's 36 APs in there, because every one of those dots you see is 4 APs. So you can get really high isolation, and you can still keep the co-channel interference really low. At the same event, there is also the actual speaking grounds, where you have tens of thousands of attendants that are going to go listen to a keynote speaker or just the daily information. In these areas, typically just a general spotlight coverage is better, to where you just beam down. Here you just see a simple mount that can be mounted to any rafter. And you can design it to where it's real isolated cells, just lined up with your convention seating, and you can get individual cells like you see here on the right. And if we actually go into this event, it was actually here in London. It was one of the first ones we did with 6 gigahertz. So we used our antennas and Juniper Mist for a 6 gigahertz event. And we did a survey at that event, and it was actually very close. We were very happy. It was one of the first major ones that we were able to do. And the predictive and the survey were very close. And then just looking at the more general aspect of the whole thing, the 5 and 6 gigahertz on both these was able to cover the entire area, very strong signal, and the same as kind of Matt had mentioned earlier. So it was great to see that, and it's impressive to design that high density. It's very fun to do. Thank you.